My name is Mr. Monroe, and we are going to investigate water, its color, and the clarity. Clarity means how clear it is. You know, water is essential to life. The primary use for water, we drink it, right? Let me ask you this. Would you drink water from this glass, or would you drink it from this glass? Which would you prefer to drink water from? I would imagine you would pick this one, right? Because this one is not looking so good. You know, pure water, I guess it's really clear. Let me go ahead and show you that this water that I'm going to drink is safe. Very good. And you know, water is important for us to drink because it is a life essential. Now, I don't dare drink this because I know that it is not even close to being clear. Pure water sometimes can be not clear. It can have just a little bluish tint to it. You know, sediment, that means little tiny bits and pieces can be in water. And the water that we're using in our everyday lives, that water has been filtered and it has been cleared up, okay? Now, Ms. Nash talked about several sources of water. The primary source of our water, guess what? It's when it falls from the sky like she showed you. And then it falls into places where it can be stored. Now, I have some water samples here that I want to show you. In fact, she showed you our pond. Now, that water in the pond is not going to look as clear as the water that I was drinking. In fact, this is a sample of the water from the pond. It's in a scientific container called a flask. And if you look at it, and it's got some stuff floating around in it. And when there's some matter or objects floating around it, we say that those matters are suspended. In this case, we have something called green algae, which grows in plants. And we know that this surely wouldn't be good to drink, right? I have another flask here, and you heard Mr. Broughton talk about an aquifer. Well, we have the windmill, which Ms. Nash showed you, and actually that windmill acts as a pump using the wind's energy to turn the blades to bring water up from underneath the surface of our planet. Oh, I think it's about 30 feet underneath. And you know what? It's amazing. There's a puddle or a big part of water that is stored in an aquifer that's trapped in between rocks. And believe it or not, when that water comes up from that well, it's just as clear as the water that I was drinking. Now, most of the time, water can be the color of what's in it. For example, there's a river that separates Texas and Oklahoma, my home state. And you know what they call that river? They call it the Red River. And if you look at the water that's in it, guess what? It does have a reddish brown color to it. You know why it has that reddish brown color? It's not because of maybe the sunlight shining on it and making it red or anything like that. And I'm going to be talking about that a little later. But it's because of the soil that is around, or it lines each side of that river. Here I have the water. Believe it or not, this is some real red soil coming from the state of Oklahoma. And I'm going to put a little bit of this in there, and we can see what happens to the water. It's a reddish brown. We can see why they call the river that runs between Texas and Oklahoma, they call it the Red River, because the water that is flowing in that riverbed, moving on down the river, it's picking up some of the soil that is along the sides of it and even running into it from rainfall, pushing it in, and it's a reddish brown. Now, you know, I've heard students ask, Why is the ocean blue? Well, if you really think about it, the light that shines on us, the light that we use to see things with, the way that we see things, light has to reflect off of the object so that we can see it. And basically, a lot of people believe that our oceans are blue simply because the light in the sky is reflecting the color of the sky into the water. That's almost correct. You guys ever seen a rainbow? And we know that a rainbow is basically sunlight shining through the water droplets falling from from the clouds. And those raindrops are actually separating the natural light from the sun into the basic colors of light: red, orange, yellow, green, blue, indigo, and violet. Well, guess what? When the sunlight is shining into the ocean, it's being broken down to its basic colors. Actually, red, orange, yellow, green, those wavelengths of light, guess what? They're being absorbed by parts of the water that we call molecules, little tiny particles of water that we call molecules. But the colors blue, indigo, and violet, they kind of mix together and they give the ocean a blue color. And you know what else, guys? If you go real deep into the ocean, guess what? That blue color is going to change into dark black, simply because the further you go down, the less sunlight you have. So I hope you kind of understand about the colors of some water. Next, I want to talk about clarity, clearness. There's a big word that we use when the older students come out here and we're testing the clarity of the water. We use the word turbidity. And turbidity means the clearness. Going back to the pond water, we know that that's not very clear simply because there is a lot of that algae floating around. We know that this water that I put the red soil into that came from Oklahoma, we know that some of the particles of that soil are floating around in there. We call those suspended particles. And it makes the water kind of unclear. And that means sunlight is not going to be penetrating it, right? Not like it would be if the water was clear. So a lot of times, plants need sunlight, don't they? A lot of times on the bottom of places where the water is not so clear, you can't get any plants to grow. We know that plants are very important, right? Water plants. I guess the best way I can kind of show that, I have what we call a sedimentary tube here, or sediment tube. At the very bottom of this, we see there's gravel. I don't know whether you guys can see that. Then it gets into sand. And then we get into a little bit of silt, real fine particles. And if you look, the water is dirty brown. And what that means is suspended particles are floating around in that. And we know that could have effect on fish too. Fish have these slits in the side of their heads called gills. And that's how they take in oxygen, air to breathe. And they swim in the water. And as they swim through the water, water passes through those gills and they get the oxygen from the water. Do you know, because of particles floating around in that water, it might have a big effect on that little fish's ability to breathe oxygen from the water. Listen, there's an instrument we use to measure how clear the water is. For example, this is a turbidity tube. If you look down the center of this tube, if I could get that to you, you see a black and white design, right? Well, I'm going to pour some of this Red River water into it. Now, we saw that black and white design, didn't we? Well, I'm looking down in there now, and you know what, guys? I don't think you can see that black and white design now because the water is dirty water. It's not very clear. So that's what clarity means, the clearness or the turbidness of the water.